Did you know that steam drum level control could be impacted by influences other than the level control valves, such as sudden pressure changes? At the end of this module, you will be able to identify the steam drum connections that have a direct impact on drum water level control, identify the specific valves that may have a direct impact on steam drum level control, identify problems associated with level control valves, identify problems associated with blowdown valves, identify problems associated with safety and relief valves. The water flow path of a heat recovery steam generator, or HRSG, starts at the condenser, proceeds to the condensate and or feedwater pumps, and then to the associated drum where the water is converted to steam and sent to the steam turbine. The typical HRSG consists of a high pressure or HP section, an intermediate pressure or IP section, and a low pressure or LP section, with each section containing an economizer, a steam drum, an evaporator, and a superheater. Within each section of the HRSG, water and steam are circulated through a series of connections that have a direct impact on drum water level. Feedwater inlet supplies water to the steam drum from the economizer. Blowdown connections remove impurities concentrated in the water during the evaporation process, and a steam outlet connection sends steam into a superheater or reheater section. These connections and the valves associated with each connection help control the primary steam drum level determinants, steam pressure, and the flow of water into and out of the drum. Since the valves in these connections impact steam drum level, the following sections will discuss the design and operation of the valves as well as problems associated with them. Automatic level control valves are designed to balance the amount of feedwater flow entering the steam drum with the amount of water and steam flow being removed, so as to maintain a constant drum level. The HRSG steam drum is a vessel that, under normal operations, contains saturated water below the water level and saturated steam above it. Saturated water flows down into the evaporator tubes and returns to the drum as a mixture of steam and water. The drum acts as a separator of steam and water, with the separated steam flowing out to the superheater, while the saturated water is again available for return to the evaporator. When operating at power and when in three-element control, the steam drum level controller automatically maintains level by matching the steam outflow with the inflow of hot feedwater, making automatic corrections to the level control valves in order to maintain the drum water level at the normal water level controller set point. The major problem operators face regarding control valves is binding or sticking. In older valves, sticking is often caused by wear, and the remedy is to replace the worn-out or damaged valve. Over-tightening of the packing during maintenance may also cause sticking valves. If the packing is too tight, the packing should be loosened to permit operation. Prior to the unit startup, commonly used valves should be visually inspected and cycled to make sure they respond when required. The valves should also be checked for leakage. A leaking valve can cut both the valve seat and the packing. If cutting into the valve seat occurs, the valve will not properly seat, and the leakage can worsen. If cutting into the valve packing, the packing may get larger in one area and smaller in another. This could result in the valve stem cocking to one side and moving at an angle. If this happens, the stem could come in contact with the metal on one side of the valve, which can gall the stem and bind the valve. At this point, the valve has to be disassembled for stem grinding or replacement so that the stem fits and operates properly in the valve. When water is evaporated to steam in the HRSG, dissolved salts can remain in the water and concentrate in the steam drum. To maintain the salt concentration at an acceptable level, the salty water is replaced with low-concentrate feedwater by a process called blowdown. Blowdown valves are used to maintain water chemistry within specifications. Blowdown valves face the same type of problems that level control valves face, such as sticking and leaking. A leaking blowdown valve provides a path for water to escape from the drum. During a unit startup or at low load conditions, where there is relatively low feedwater flow, the flow from a leaking blowdown valve could affect the drum level. At high loads, a leaking blowdown valve is not easily recognizable because of the high feedwater flow rate as compared to the flow through a leaking blowdown valve. There are three types of blowdown: continuous, intermittent, and startup. Continuous blowdown is the continuous removal of water from the drum. This helps maintain the water chemistry within specifications. The amount of blowdown is adjusted manually based on samples from the drum. Continuous blowdown valves tap into the drum near the normal surface level of the water. Intermittent blowdown is designed to remove suspended solids, including sludge that might form in the HRSG water. The blowdown takeoff point is usually located at the bottom of the drum or at the lowest point of the evaporator. In practice, the intermittent blowdown valves are opened periodically in accordance with an operating schedule. During a unit startup, the intermittent blowdown valves may be used to remove excessive water from the drum if the water level becomes too high. These valves should be used for level control at low drum pressure conditions only, such as during a unit startup. Safety and relief valves protect plant personnel and plant equipment by discharging excessive pressure before the design pressure of the component is exceeded. Safety valves are typically installed on the steam drums and the main steam lines. Relief valves are typically installed on the inlet of the low pressure and intermediate pressure economizers. Safety and relief valves are rarely cycled, so corrosion is the main cause of binding. Because of the consequences of the failure of these valves, they should be tested in accordance with plant procedures. You have reached the end of this module. In this module, you learn to identify the identify the steam drum connections that have a direct impact on drum water level control. The feedwater inlet blowdown connections and steam outlet are the three important steam drum connections that have a direct impact on drum water level control. Identify the specific valves that may have a direct impact on steam drum level control. Automatic level control valves, used to balance the amount of feedwater flow entering the drum with the amount of water and steam flow being removed, so as to maintain a constant drum level. Blowdown valves, used to remove the excess water from the steam drum during startup to control the drum water level and to remove suspended solids that might form in the HRSG water so as to maintain water chemistry within specifications. Safety and relief valves, used to discharge water or steam when pressure limits are exceeded. Identify the problems associated with level control valves. Binding or sticking and leakage are the common problems associated with level control valves. Binding or sticking is caused by wear or over-tight end hacking. Identify the problems associated with blowdown valves. Leaking blowdown valves can affect drum level. Identify the problems associated with safety and relief valves. Binding is generally caused in both of these valves due to corrosion.